Alrighty, well, good morning, everyone. Welcome to the Wednesday, January 10th Ambient work group meeting here. And so first up on our agenda, we have Stephen Landau talking about waypoint sandwiches. Let's see, is Stephen on?
Yeah.
Okay, there we go. All right, Stephen, take us away.
Yeah, so I'm pretty sure everybody at this point is pretty familiar with the general idea of sandwiching. cTunnel handles all the encryption, and then the waypoint can take it over. We have two ways we could do it. We could either have the waypoint use the node cTunnel, so the waypoint would just behave like any other app in the mesh, or we could do something where we're using zTunnel code, and then do something like zTunnel as a sidecar to the waypoint. It's actually pretty easy. I have a proof of concept that just does uses the regular node traffic capture to give the waypoint MTLS. So that would probably be what I would choose to do. It seems like it's a bit simpler to set up versus having a sidecar model, unless of course the waypoint is not in the cluster. But the main thing I kind of wanted to focus on was the protocol between the zTunnel and the waypoint. So I have a prototype which pretty much just uses proxy protocol to tell the waypoint what the original source and destination are, and then a little custom out-of-band thing that adds some TLV headers and proxy protocol with the spiffy string and a really simple Envoy custom filter that takes that spiffy string and uses that as the peer identity for authorization policy. The additional things, well, I don't know, right there, I think proxy protocol was something that people in the past had been supportive of using, but I didn't know if there were any major objections to doing that. Okay. So the main new thing in this proposal that hasn't really been talked about much before is what we send in the proxy protocol to communicate identity. Right now, I'm just sending in my prototype. I just have it sending a plain string with the spiffy URL, but any zTunnel could tell any waypoint, hey, trust me, I am. This is the identity that I terminated, and continue to operate as if this is the identity giving you the request. Instead, what we could do is have the origin zTunnel generate or receive a JOT and forward that along. And so that is something that only the origin zTunnel would be able to receive from whatever JOT issuer we choose. And along with that, we can embed additional metadata. So a couple of the advantages are that we can actually cryptographically verify this JOT and make sure the claim is actually generated from something that's trusted. And the second thing is that we can add additional metadata.
So that still allows the waypoint to modify the message. So it's not full encryption or signature, but it at least gives us some idea that this message originated from the client it claims to. How does the server zTunnel validate that?
The application. Go ahead.
So the server-side zTunnel can choose whether to validate the JOT or not, but when it passes the JOT to the waypoint can validate the JOT. So what that does is it prevents impersonation of attributes of the client workload by the waypoint zTunnel.
But why do we not trust our own zTunnel?
So we can choose to do that, right? So they're just degrees of trust, right? And we could just choose to straight up trust it, which is what Stephen has already implemented. The question is, like, this is just basically a review of potential attack vectors against waypoints, right, to get them to misimplement policy, or for any workload receiving traffic. The simplest implementation is to just do what Stephen has already done: pass identity, pass other attributes, and rely on the physical connection between the z-tunnel and the waypoint to say that those two things are coupled, and that's secure enough. If the waypoint z-tunnel was attacked and compromised, but the waypoint itself was not attacked and compromised, signing the information would prevent the z-tunnel from being able to impersonate or arbitrarily modify the attributes of the traffic to get the waypoint to misimplement policy. We could just say that that's not really a high value or likely attack vector and just go with the simplest implementation. That's perfectly fine. But we should give this some thought.
Yeah, it seems like if you do take the case that your inbound z-tunnel is compromised, you are relying on the z-tunnel to verify the MTLS attributes match the JOT. So
yes,
I feel like we're not really getting the security benefit there that we want.
This is not identity protection. This is only protecting against the metadata. It's protecting the metadata from being spoofed.
So it's a bit more nuanced than that. I mean, there are three or four things that are at risk here. I mean, one is the workload should not have access to the original JOT from the user, because the workload may take the JOT, exfiltrate it, or use it for other things. The waypoint should not be able to impersonate arbitrary users, because again, if it's compromised, you need to pass the statement from the client to have some signed statement from the client, and probably some combination. But my point here is it is high value. I think it's very important to support this kind of means, JOTs, whatever they are called. But the simplest implementation should probably stay simple, and this should be optional and kind of maybe after beta or at a later point or through a separate API or model, not necessarily something we want to do now.
Yeah, so you can defer all of this and do what Stephen's already done. Just pass identity, pass metadata up to the waypoint or the application in the proxy protocol using TLV, and call it a day. That's fine. And then we can come back and see later on down the road if we think there's additional protection that needs to be added.
Yeah, no, I'm super supportive. I think it's super important. It's very nice. It's just I want to make sure we ship the simple thing first, and then we get feedback, increment, and add them step by step after the beta.
The only other additional case, and it doesn't really have anything to do with the delegating up to the waypoint or passing the information. The easiest way to pass metadata from z-tunnel to waypoint is to use WDS's metadata mechanism and just basically encapsulate that in TLV. That works for everything where the control plane for that z-tunnel has visibility for the peer. But in the multi-network case where we have federated control planes, at some point we'll have to pass the metadata between the z-tunnels and not be passing it in WDS because we won't have global discovery. And so we'll probably use JOT to do that. But that has no bearing on what we pass up in the sandwich.
So really to confirm, the waypoint will pass some JOTs from the client to the server, because we need what you said,
No.
federation, and not at all?
Not at all. No, that thing I just talked about is a z-tunnel only feature.
Oh, but waypoint will. Okay, sorry, I get it. Yeah. So the user, if it's an HTTP request, the end application will still see some identity and will be able to know who's calling, the JOTs. You are not going to remove any information from the request.
Oh yeah, we don't touch what the user is doing at all.
Well, at some point we may want to. That was my point. That if you want to the user to not see the original token or to have signed statement from
but that's a feature of the waypoint that's specific to the waypoint.
Okay, got it.
And what about the reverse flow? How do we get metadata from the server to the client?
Are you asking? So right now, the client, are you talking about telemetry jot or are you talking about policy? Right. Because
well,
today we don't.
The third requirement, Waypoint has a way to receive workload metadata for telemetry.
Yes.
So the S metadata about S in the picture.
Yes. So Stephen, because the Z tunnel sees both the client and server identity when forwarding traffic over the proxy protocol, it can also pass the server's metadata in a TLB.
But that requires that load balancing, this decision is made earlier, right?
Oh, you're asking about if the client is addressed a service as opposed to a workload. Is that what you're asking for?
I'm asking about the second arrow from Waypoint to the server.
Right.
So how does Waypoint get server metadata?
For outbound telemetry, not inbound telemetry.
Well, it doesn't. I mean, Waypoint doesn't. It has to report telemetry about C and S, right? So I know how it gets T, but how does it get S?
Yeah, I agree with the question. I was just trying to clarify it.
Yeah.
Are you asking about L7 or L4?
I don't really care. I mean, this is not about L4 or L7. It's about.
Well, they have different answers because for L7, again, if Waypoint should be able to see, Waypoint is one generating L7 telemetry, so we'll have ability to get all the headers we have today or whatever other JOTs or whatever other information. It's a rich environment. It's not a problem. For L4, it's a bit more nuanced because you may only have access to very little information, and then you need to look up either to your workload discovery service or other things because you have the identity and you have the IP. You can look it up.
Yeah, so that's the problem, right? If you're going to have to look it up, then why do you have to look it up only server, not client? In the most cases, right? I mean, if the protocol doesn't let you send it on the wire, so you have to look it up separately. So just look at the client as well, right?
You don't have to look it up in all cases, and you don't have to look it up in either server or client. You can just push it to telemetry, and telemetry pipeline can look it up. It's not necessarily that it's in line. And you need it if the user says that I want rich telemetry. I mean, it's not. I don't think it's a huge deal or a problem for this.
And so it's a fair question, right? Like post load balancing, when we select the server IP, how do I get telemetry? How do I get metadata for it so I can generate telemetry? As Costin said, you can either look it up using WDS, or we can push it inline into the endpoint definition for the workload, for the waypoint itself in EDS, and do it that way. Right, those are the two options.
And why can't you do the same thing for client? Is that because of like cost network or something?
Well, because the client is already known, right, at the point at which the traffic enters the waypoint. So it's immediate, right? We don't know the destination. We don't know S until load balancing occurs, and load balancing is done by W, right? So we can't inline it unless we inline it.
Yeah, I understand that. It just seems like awkward because you have a zip down on the server side, but you don't use it.
Right, so L4 telemetry, right, the ZW, right, can perform that just fine. It's only L7 telemetry where we have a problem.
I think a bigger question is do we really need all this telemetry? I mean, does the client needs to know the exact information about the server, or is it sufficient to just have version and canonical service? And canonical service is kind of implicit. We may try to solve a problem that, it's better not solve because that result in high cardinality and a lot of other problems. Maybe we should look at simplifying the telemetry as well in this situation.
Well, I mean, same thing can be said about policy, right? It would be better if policy was sent by Z-tunnel than tested somewhere else, right? I mean, fine, maybe label is not important, but identity of the server seems like could be useful.
How about keep policy and telemetry aligned, and whatever they have for one, they have for the other, and not add more for telemetry? So we have the certificate JOT.
Well, for example, it makes sense to say things like waypoint has to verify that this server is what it claims to be, like service account. But with this picture, there's no way to verify that because that information is lost.
So the waypoint verify or the Z-tunnel waypoint verifies the identity of the server, and the client verifies the identity of the waypoint and Z-tunnel waypoint.
Well, let me just walk you through. Like, so if I send a message from waypoint to server, I would want to say things like, server is identity that it was supposed to be. But because I'm sending plain text to ZW, I cannot get that information back.
Right, but ZW and ZS can do that, right?
So it means we need to delegate this check. So I need some kind of policy transmission from W to ZW saying, I want you to verify that ZS is this at ZW.
I think I understand what you're saying. Yes, that's probably the case always. So the client should be able to indicate somehow that the identity of the server that it expects for L7 at least, but for L4, it's usually based on the IP just like it is today. I mean, for L4, we, even Envoy today, you get an IP, Envoy doesn't know anything except the destination IP, which is a service IP, and then from that it can derive other information. So, for example, if we use SOX 5, you would pass the hostname, the fully qualified hostname. So we should have a protocol between W and ZW to pass high-level FQDN instead of just IP.
Sorry, Jay, you had a question.
I just wanted to make sure that we didn't lose in this discussion. If we're talking about simplifying telemetry, and sorry, I can't type, so my message got messed up. But if we're talking about potentially losing destination workload information at L7, we can't do that, I don't think, other than the destination pod. But destination workload namespace, all those things, the version. That's fine. Just making sure.
Oh, hold on, Costa. Right. I mean, Quat's point is today, naturally, without getting metadata about S into W, you would have destination service naturally, right? Because that's what W is going to serve. Right. So if you want, in a waypoint case, to know that C is talking to S from telemetry, and for S, namespace, identity, or some aspect of the deployment, you have to get that metadata for S into W if W is going to report that telemetry at L7. And since W is the only thing doing L7, really, in this diagram, that would have to occur.
So basically, what we are saying is that the communication between ZW and W, both of them, incoming and outgoing, should have ability to pass some metadata from L4 to L7, which includes identity and information and whatever claims are extracted from the identity at L4.
Well, seeing as L7 is W is the only thing doing L7 reporting of any kind, right? Because all the Z's are completely unfamiliar with L7. If the telemetry has to be resolved at the L7 level, W is the only thing that is capable of doing it, so it has to see all the metadata.
Or should see the attributes from the lower level. Yes, I agree.
Right. And there are two ways to do that, as we noted before.
For telemetry, yes. I mean, I think what also is the issue of security. I mean, how does W verify identity of S at L7?
Well,
because
but let's leave the secure naming concern aside for the moment. Let's just focus on telemetry because it's actually probably more difficult. I think there's like a slightly different answer for secure naming. So at the telemetry level, what features of the L7 protocol do we need to know? We need to know requests, right? Because we count requests between C and S, right? And we also count latency between C and S.
That's right. I mean, just to confirm, right? I mean, basically you're talking about request total and duration milliseconds type information. That's what we need. And it can be reported just once from the waypoint if that information is all gathered at that point. It doesn't necessarily have to be reported twice like we do today.
Yeah. Now the alternative model is to change the telemetry schema, and instead of reporting telemetry between C and S, we report telemetry between C and the service that S is part of. So there's one set of telemetry which is C to service, and there's a separate set of telemetry which is service to implementation.
When you say service, do you refer to the waypoint or something else?
No, I mean literally like a Kubernetes service. All right, remember, there are two types of traffic going into the waypoint. One type of traffic is already load balanced, where S is already known, and that's an easy case, right? We call that two workload traffic. The other situation is where you're going into W, and W has to perform load balancing, right? So that's a service. And we call that two service traffic.
I'm not sure that it's all that useful to have just the service information, right? That kind of comes right from the request.
Yeah,
right?
But
the waypoint can do all kinds of interesting things, right? So, if you've got 3 versions of S as workloads, you need to know which version it actually went to.
Well, I actually, do you need to know which version it went to, right? Because we're talking about telemetry here, right? We're talking about request total and latency. Or do you want to know which version of an implementation of this service is fast versus slow? Because you can know that just by having telemetry between the service and the implementation. You don't have to know it between the client and the service, between the endpoint, right? So you can have 2 metrics instead of 1, right? Hopefully.
if I understand what you're saying, I think that that is true. You know, when we think about a visualization of the traffic, when people make a request of service foo, and it gets routed to a foo1, foo2, or foo3, as long as they can see the percentage of traffic routed to each of those versions, and they can determine the latency for each of those paths, then I think it would be okay.
Right. This is right, because that would look much more like a normal proxy's representation of traffic, right, as opposed to what we do with sidecars.
So is there any objection to WDS for telemetry? I mean, using as a generic mechanism, and any doubts that it solves the problem of telemetry?
No, I don't have a problem with it.
I don't have a problem either. I think we need to make sure security is fine. I mean, secure identity, secure naming. Because if we are okay with that, then we can, probably extend it later, have additional extensions to the protocol later to optimize if WDS is not sufficient by itself.
So either
Yes,
WDS or EDS.
Yeah, both of them.
John?
Yeah, it seems like our issues about getting the metadata on this arrow, but not the client arrow, is about our use of proxy, which is really only, doesn't really make sense in this case. If we had used one of the other metadata passing mechanisms, like the metadata server, not the metadata discovery service, but like the HTTP service, or like the socket option, all of those would allow the waypoint to just open up the socket and then read the metadata about the socket and not necessarily need to know about what the destination is. Now, that being said, given that it already has to do load balancing and all this other stuff, it's maybe a bit redundant, but it would still, that is another option.
John, I agree with you, and that's what I meant earlier by saying that we can extend the protocol later. The question is it required to do it now and to have more complicated protocol, or can we live with AJ proxy as a baseline plus WDS for telemetry, knowing that we can address somehow the secure naming, which Quat raised it. It's a very valid point, and I need to make sure that it is clearly covered. And then add the extensions later. I mean, definitely some metadata server, WDS, EDS, and other mechanisms will be part of the solution and as extensions or other things. I mean, the question is AJ proxy by itself a valid solution? If not, then we just scrap AJ proxy, and I mean, there is no point if it's not sufficient anyways. Then, but if it is sufficient as a baseline, then we should go with it.
The issue is how many policies we have that combine L4 and L7. Like if you have a policy that has both parts in the predicate, it's going to be hard to create connections to every L4 policy based on the L7 attributes. If you're saying things like, this sub-request go to identity X and this sub-request go to identity Y, and the IPs are shared sometimes, where X and Y are wildcards, it just becomes really complicated.
We only have identity based on the incoming side, so we don't have egress policies. The policies is on the ingress. And that's based on the identity of and L7 is separate from L4 anyway.
Right. The only egress policy we have today is secure naming. Right. Is the identity of the peer who we're talking to permitted to be an identity that's part of that service?
Yes, but that's just because our policy was applied at sidecars where identity of the destination is implicit. Once you start sharing proxies with many identities behind it, you need destination policy to mention destination identity as well.
Or you trust delegation, right?
Or you force that waypoints are the isolation boundary, which is not always the most efficient way.
That's what we are doing, right? Like it is trust. Like the producer, because S owns W here, right? Logically, because they're part of the same namespace. S is trusting W to act on its behalf. Right? That's what this setup means.
Yeah, I understand, but it's a logical, right? I mean, W's can be shared physically. So in that case, every logical W inside physical W will have to create connections with different policies to ZW.
Right, but that's implying that W's are multi-tenant, right? And that's a vendor-specific thing currently. If that's going to be the case, if vendors want to do that, then they have to meet those requirements. Istio's W's are effectively single-tenant, so they get this by construction.
That's fine. It would be fine to support a way that doesn't require transport topology, right? Because of this assumption that W assumes identity of S, you also force in the different network topology. And that's constraining because now you have to have physical connection between W and ZW for every logical S, right?
For every logical S.
Well, it means that every time you want to, if you all your W's are just one physical W, then to be able to talk to different S via ZW, you have to create a new physical connection to ZW.
Yes, because the connection represents the identity of the two peers, and that's what we rely on to validate. Like that's what HBone does. So yes, that is currently a limitation imposed by ZTunnel, right? Like ignore W, even. Right? ZS only knows the identity of its peers by physical connection.
Yeah, so that needs to be sort of recognized. I'm not sure it's a good idea to force this.
Well, that's what every VPC does. Every VPN and VPC does that. I'm not doing anything novel there. Right? If people want to layer on higher level delegated identity, they're welcome to tunnel on top of that. But right, trying to do something beyond what every standard VPC or VPN does by relying on binding physical connection to identity pair, right, that's pretty far out there. But that does then create a requirement on multi-tenant implementations of W that want to impersonate many different identities to create many different physical connections. Or the authorization system permitting them describes how they are delegating. And basically those connections are described as superpowers that are allowed to impersonate whatever they want.
Yeah, I think that's the most common approach for multi-tenant services. I mean, if you have a gateway, multi-tenant gateway today, that has its own identity, its own mechanism to be verified either to CIDR range or its own identity, and you don't have to create multiple identities in the gateway. Gateway, it's identified as a gateway itself, multi-tenant or not.
Right. So you have a policy that says W, or the identity W, is allowed to talk to all S's, right, or something along those lines.
And the SS accepts connection only from W and for some G's that are separate, right, not in this picture.
Right. So basically, like it's a multi-tenant W is exactly like an ingress gateway, right, in terms of policy posture. So coming back to secure naming for a second, right? Secure naming is one of the least understood features of Istio, right, when it comes to user understanding. In stock Istio, right, because W and S are part of the same namespace, right, there's a fair amount of trust created between them. And the biggest problem with secure naming was a solution to basically a DNS ejection style attack where somebody put an endpoint into a service that was not part of the same trust domain. Right, that's what it was designed to protect against. It's not clear that that is a problem in the stock Istio use case where W and S belong to the same namespace, and W can easily perform a check saying, hey, is S part of the same namespace? It's not quite the same check, but it's a very similar check.
Actually,
I'm
I
not
think it's, yeah, so sorry to interrupt. I wasn't sure if it should.
Oh, go ahead. Yeah, so I'm just not sure if for the default Istio setup that this is actually a concern.
Maybe it's a good idea to separate a bit and to the simplest and the most common case. I think that telemetry can be addressed WDS and PDS. I mean, we have plenty of solutions. Using telemetry which needs to be a concern. We are perfectly fine on the incoming side, I believe. I mean, with either AJ proxy or pretty much any other protocol, we can get information on the inbound side. The only thing we need to confirm is that we have a solution where W can express what is the expected identity of S, because that's where the confusion can be, because VW will only see basically an IP. If it only sees an IP, then it's subject to, we have lots of information. I mean, it's anyone can take over the IP with pod IP being reused aggressively, so it's a problem. So we want to make sure W can pass FUDN or some other or service account of S, and we don't rely exclusively on the pod IP to security identity in L7.
Are you okay with ZW doing that on W's behalf?
If it has the information, the problem is ZW should have an information about, hey, I expect example.com, not ZW having just 1, 2, 3, 4, which maybe, another pod just replaced the example.
Well, like take the simple example. All outbound traffic from W must go to something in the same namespace as W.
If you have W in the same namespace, yes, but for multi-tenant or per cluster or per, multi-cluster, it's not so easy to enforce that.
So how does W tell ZW what to check?
Could do a SOX connection, could send, can pass some AJ proxy, make an AJ proxy itself, where one of the attributes will be the expected, the SNI. I mean, there are plenty of ways to pass some, whatever you want. I mean, it's just a matter of passing the L7 identity from W to ZW, so ZW knows what to check. So that's really what we need. So many solutions, I don't want to get into any of them.
Yeah, I'm just not sure if it actually has value. That's the only thing I'm wondering.
The value is ZW will know expected L7 identity, which otherwise would be lost. And then ZW will only have an IP address. And we are back into the problem of IPs can be reused, and they're not, and then we need to be super sure that the IP that ZW connects to is actually the same one that W thought that it was connecting to. Since, again, pod restarts, IP reassigned to a different pod, you are in bad shape. Not problem if W is per namespace, as you said. I mean, we are probably okay with that. But as we go to gateways plus the tunnels, or we go to multi-tenant waypoints, it's a problem.
Well, gateways already don't do this check, Custom. Right, ingress gateways.
They do now, because there is a new API in Kubernetes Gateway backend TLS policies that allows user to express that when you connect to S, expect that particular DNS certificate.
Right, but that's application level TLS, not secure networking. Right, different
Part
thing.
of the API, users don't care. I mean, that's how that certificate is there. It's not that problem.
HBOON and TLS are an implementation detail, right? They are not an application feature, right? Those APIs are for application features specifically, right? So we're not going to use those APIs, right? The only API that exists that reasons about this today is the secure naming API, which is not really an API, by the way.
Yep.
So I would suggest the simplest thing is if vendors want to have multi-tenant waypoints, they just treat them as superpowers.
I see. That's fine as well. So basically, if it's same namespace, it's fine because eTunnel always check same namespace and not care necessarily about the service account, just the namespace. I can live with that.
Right, because ZW, right, like consider a multi-tenant case. ZW sees, right, the problem is that the view of the world that W sees is different than the view of the world that ZW sees. W picks an endpoint for a service. It thinks that endpoint is part of this namespace, right? It then says to ZW, hey, I want to connect to this endpoint, right? And ZW says, great, I'll connect to that IP for you. It connects to it, and the peer identity that it gets is not the same one that W was expecting, right? So there's a configuration propagation issue. Yes, I mean, you're right. We could pass down the identity that W was expecting, right, through proxy protocol. ZW could try connect, validate it. If they don't match, reject the connection. Sure, like it's not that complicated. And like I think we could reasonably add it. I don't know if we would use SOX. SOX is a little more heavyweight than proxy protocol and TLV, and we'd still have to eventually solve it for UDP. And John's probably right that probably at some point we'll just use socket options to do that. So I would say in the short term, the easiest thing is just not do it. Rely on same tenancy for the typical case. Vendors can decide, and we could go add socket options or something else later to solve this problem. Does that sound acceptable? No, I mean, WDS, socket option, right? Like there's obviously, we have a variety of different ways of getting information across the boundary. But that's the trade-off for getting a ton of convenience, right? With the sandwich. All right, it's not clear that we're going to resolve this conversation in this meeting.
Can we
Can
come
we
next
resolve it?
for Stephen?
But Louis, what is the controversial? I mean, I think we are more or less on the same page. I mean, I don't think do you disagree that it's viable to do this with?
No, I mean, for the simple case, it works fine. If you just have, WNS at the same identity and GW is always very high in one thing, it works. I'm also concerned about
We can extend it, and we can extend it later. I mean, it's not the end of the. I mean, it's just a baseline, the most common case, and with extensions later, in future versions.
Well, the extensions require new protocols. That's the problem.
That's perfect. I mean, it's not. We never said that HTTP2 over Connect is the only protocol, or this is the only option. I mean, it's just bag.
Well, there's a difference between solution and then future tech debt. So I just want to make sure we sort of anticipate that this might not be that long term.
What I like about this is that it would work with any implementation of ZW because it has a minimum impact on the lower level or L4 security. So this would work with arbitrary implementation, so it has the broadest chance of adoption. And then we can have more optimal solutions with specific implementations, which is fine.
The goal here.
Sorry, Louis. I just want to do a quick time check. So we have 9 minutes left in this meeting, and there are still 2 other topics. Do we want to carry this offline, come back, revisit this issue next week, or do we think we can resolve in the next 9 minutes?
I think we have to take it offline if we're going to get to the other 2. I don't know.
Okay. So shall we move on to Ian's topic?
Yeah.
I'm assuming silence means consent. All right. Yeah.
All right. We can do this as like I guess a request for comments, really, to just in the interest of time, to make sure we get to Lynn's. But basically, we have a question outstanding for Z-Tunnel. And it's basically if RBAC is updated, should we close the existing connections or let them live on? And if you have strong opinions about this, please put them in the issue ASAP. Right now, we are leaning to we should close, I think.
What's your timeline? Are we trying to close this issue soon?
I think this is considered a beta blocker. So we would like to either close as we're going to leave them open or begin implementation as soon as we can.
Yeah, so I don't see a contention point for this. I think if I recall correctly from the GitHub issue, most people are in favor of reapply the new RBAC update and drain the in-flight connections as soon as possible. Ian, do you see a contention point? I just want to make sure people understand what the options they are evaluating.
What RBAC are we talking about? We don't support any RBAC.
Authorization policy.
Yeah,
authorization
policy.
Okay.
And also people make a change to the authorization policy, I think, in this context.
Yeah.
No, I get it. Please don't use RBAC because we have a separate discussion where we are just discussing we don't have RBAC and we never supported RBAC.
Yeah. Good point.
Even us, we are confused.
Fair. Yeah. Sorry. The L4 policy. I don't think, Lynn, to answer your question, I wasn't seeing much contention. John, I guess, had originally sort of said he would prefer to leave them open, but seems like he's come around to we should close as soon as we can. Just wanted to make sure before we started working on it that no one was going to object.
Yeah. Is there anyone have strong opinion? Probably good to say it now. And, because I think Ian, you're looking at start working on this, so we can't have the design open for a very long time. We really want to close the design, the behavior as soon as possible.
Yeah, I don't have a strong opinion, but at least from the CNI space, I've seen an example of both. So I think both are acceptable.
Are both there may be good CNIs and bad. This is my question as well, Yuval. You've got a long-lived connection. it's just something sensitive like a database, you're being actively attacked, you push a policy, nothing happens, you're probably very unhappy.
Yeah, no, I agree. Like I said, I don't think I don't have like a strong opinion. I'm just saying that I think Cilium, for example, only does a policy on initial connection.
Really?
I'm just saying I've seen example both, so I think either will be acceptable for the market, for the users.
I think probably for their Envoy policies, that's true. But I think some of the other policies are per packet, so they're not really even related to.
Yeah, and but they also have connection tracking, and if the packet is part of a connection, they don't do the policy again. I can show you the code.
Oh, they skip an entire. Oh, okay, interesting. Okay.
Can we track this down, because this is like understanding what is common practice is actually important.
So I think that it is desirable to take for policies to take effect right away. You do not want a long-lived connection to be bypassing the policy that just got applied. But as somebody was saying, Yuval, maybe that even most Kubernetes network policies, they rely on connection tracking. So once the connection is already established, they don't apply policies on established connections. So is this proposal to go back and look at established connections, or there was some talk about quote unquote training an existing connection? What is the precise thing being? So my opinion is that policies should take action ASAP, but what is the action being proposed here? Killing a connection, draining a connection? Can you please specify?
We're trying to discuss what's the right behavior for the tunnel.
It should take action, but I'm trying. I thought there was a specific action already in mind here, which is either draining or killing a connection.
Yeah, I mean, essentially, I think the question is, you've got an in-flight connection. Someone updates the policy. That connection should now be a deny. If it was made right now, it would be a deny. What do we do? Do we just let it proceed? It has some natural lifespan, and whenever it closes and they try to reopen it, it's a deny? Or do we actively go through and say, well, this is now denied traffic, and close it?
And the behavior of zTunnel today, if I'm reading the issue, is right now we don't do anything. Is that right?
Yeah, I believe so.
I would say that the correct behavior is to actually close. Either draining or close immediately are fine, but you want to make sure it's not, we don't promise anywhere that it will be instantaneous. I mean, with some, few second, minute delay, it's perfectly fine. And if we want to drain, we can drain. It's not really, but nothing is definitely not the right answer.
Okay.
But in order to, are we proposing going back through the connection tracking table and sort of figuring out which side initiated the connection and sort of auditing all existing connections to see which one needs to be killed?
So you can just close connection, close socket, no?
Yeah, I think we would need to keep track of all the outstanding connections, loop through all of them, reapply the rule, and then close them.
Yeah, I think at a very... Oh, sorry, go ahead, John.
Hey, I was going to say not super hard, but also not trivial. Like, obviously, somewhere in the process it knows all the connections that are open, but they're probably not in such a way that it's just trivial to iterate over them, but I'm sure it can be done.
Yeah, I think the minimal solution would be to go through our cache of connections that we're maintaining and try and do something with that. But yeah, it's not trivial, I don't think, either way.
Right. So I think the desirable result is to have policies apply immediately, but many implementations don't do it because of the implementation complexity, and many network policy implementations also don't do it. So perhaps you could augment the proposal saying what exactly you propose to do, and if it is possible to sort of re-audit all the connections efficient manner, then yeah.
So I think I kind of agree. We should look at what's out there in the existing market for CNI and what's the behavior they have, right? To trying to understand. I think that catalog of analysis of popular CNI and their behavior is probably worthwhile doing, and that would help us make a decision if this is acceptable for beta.
Well, what is the, do we know what's the complexity for this thing? I think we all agree that if it's easy enough, we should do it. But maybe we can get like an estimate for that.
Yeah, I don't know the complexity. I don't think it's going to be like a whole mountain of code, but I also don't think it's trivial. I'm pretty sure we don't currently track this anywhere, and I don't think we have any way to talk to an in-flight proxy process and tell it to cancel. So those are probably the two things that we.
I mean, my hunch that if it's like a week of work, it's probably worth just doing, and if not, then maybe we should look into what's acceptable. I can even look at the code because I've been restructuring the way the proxy works a little bit with my input proposal.
Okay. Yeah, I can probably take it offline with you a little bit, and we can chat.
Yeah.
All right.
Yeah,
and I
that
burned up all of Lynn's time anyway. Sorry.
No, it's good. I think I like what you guys said. I mean, implementation, have a timeline on implementation is also important as we get through beta. So, yeah, for me, thank you, Ian, for bringing that up. For me, it's really quick. I just want to let everybody know I've done a first pass of review existing annotations and labels. I encourage everybody to look at the doc and comment on it. I think as far as beta, we need to look at some of these annotations in there and determine, do we need to support them for beta or not? That's the ask. Okay, should we wrap this up? I think there's a couple of design doc I'd encourage people to check out. I think, Carsten, you have an OSC gateway doc, and Louis, you also have an updated doc on OSC. So there's a few things I encourage folks to check out because we do need to reach consensus on OSC really soon.
My doc was mostly in the concept of Istio as a whole, not only ambient, it's across even for existing gateways. But
okay,
yeah,
that's
please.
good to know.
Lynn, did we get to address your last topic here?
Yeah, I'll just ask people to review offline, and then we can discuss next week. Because it's already over. Thanks, everybody.
Yeah. Thanks, everyone. Thank you.